Hi everyone. We're going to talk about linear modeling today. Um, Here's an example. Let's look at it. Um, if you drive a car at 60 miles per hour, then we know that if that's the first hour, and then you're going to drive 60 miles times 1 hour. So you totally drive 60 miles. If that's 2 hours, 60 times 2. So on and on. If I say, oh, that's T hours, 60 times T. What is this? This is the total distance. Am I right? But in this case, we say that you already drove 50 miles. So what's the total distance? So if the total distance is y, then it must be what? The distance you drive in T hours plus the original 50 miles. So this give you what? The total distance. We say this give you a feeling of what? Of the math modeling. So math modeling is using, especially the linear modeling, you're using the knowledge of linear functions into the real situation. We're going to introduce you two types of application. This is the first type. Here's another example. Okay, you pay power bill. So you use how much, then you pay how much, all right? So the total bill it consists two parts. One part is what? The base fee. The basic, no matter how much you use, you pay $31 per month. And then the other one is what? By per kWh. If you use, like say, 1 kWh, you need to pay 0.15 times 1. If you use 100 kWh, then you need to pay 0.15 times 100. Plus what? The base fee. So the total bill you're going to pay equal to the 0.15, that's the unit price, times the power you used, which is X kWh, and then plus the base fee. So we call this a modeling. We say those previous belong to the first type of application modeling. So here the condition, you generate the equation. There's another type, actually we already mentioned this in previous session, that I give you a table. Those are the population in Georgia since the 1960s. And those represent the years since 1960. So there are two ways to find out a line, we call this line, to represent this model. One way is you only use what? The first 2 points. So which means you have 2 points, 0, 4, and then 59.7. So we say your m equal to 9.7 minus 4, and then 50 minus 0. So you know this method, you have 2 points, all right? So this give you 5.7 divided by 50. If you still remember, the answer is 0.114. Okay, which is your m. So now you know your function will be 0.114x plus b. You do not know what is b yet. And here you plug in this point. At this point, x equal to 0, y equal to 4. So times 0 and then plus b. So this way your b equal to what? So now you know your modeling is a y equal to 0.114x plus 4. So that's good. So that's your modeling. So that's the model to indicate how the population growth in Georgia, changes in Georgia. If you want to know how many population, this is 50 years after the 1960, that would be 2010. So how about 60? That means 2020. How many population in 2020? You just basically plug in what? This 60 into this function. So your y equal to 0.0 0.114 times 60 plus 4. Am I right? So this will give you y equal to 5.14. Okay, you need a calculator again. So I did not use a calculator. So about this many population, this is the true data. So you can find out if that's the truth. It must be close than 5.14 million population in Georgia right now. Oh, this year actually 2021, but we just passed the 20. So that's the use of modeling. But this modeling is not a very accurate. Why? Because you only consider what? 2 points. That's one method. The second method is what? You consider all the points. So if you consider all the points, you're gonna have what? The least squares line, we call this regression line. You will have to have what? A graphing calculator, how to use this. I'm going to attach an actual video here. So teach you how to use the graphing calculator to find out the regression line. That's all about the modeling. And if you have any question, you know that you can always contact me.